So the next stage of this digital transition is to reclaim some of that spectrum that could be made available, specifically the spectrum capacity that's known as the white spaces. There are several kinds of white spaces in broadcast television spectrum. The most prominent in the discussions in the US is the spectrum between existing channels. And again, there's something similar in Japan, but the examples I have here are based on the precise configuration in the US. When broadcast spectrum was set up, there was a great deal of concern about interference between stations in different cities. So if there's a transmitter in New York City, the signal continues out past the borders of the city. And if there's also a transmitter in Philadelphia, another city, there's an area of overlap between the two signals. Traditional television receivers are very dumb devices. They couldn't tell whether the signal they were seeing on one channel was coming from the New York transmitter or the Philadelphia transmitter. So the solution was put the New York stations on a different set of channels than the Philadelphia stations. In New York City, they have television channels 2, 4, 5, and 7. And in Philadelphia, they have television channels 3, 6, and 8. The other channels in between are empty. Even within the existing allocation, nothing is allowed to broadcast there. This is wasted capacity. It made sense to make that decision decades ago when television was set up. But technology has come a long way since then. Today's devices are smart enough that we no longer need to waste so much white space capacity. So the great opportunity today in the digital transition is to reclaim this white space capacity. This is a debate that we are now having in the United States. It's not usually described as part of the digital television transition. But as I've said all along, these are part of the same process. This is about making available new capacity. And these two issues are also connected because using the white space creates the possibility of interfering with adjacent television channels. The fear of interference is greatly exaggerated by the incumbent users of the spectrum. But it's an understandable concern, and it makes sense for policymakers to protect against interference with existing television services. The potential here is to make available vast amounts of new, high-quality spectrum. Spectrum in these VHF and UHF bands has better propagation characteristics than the higher frequency spectrum that's used for mobile phone services. So not only is it more capacity, but it's capacity that is very good for reaching into homes and across large areas. A variety of technological innovations in wireless now make it possible to take advantage of this white space spectrum. As I've said, these wireless devices are computers. They are very sophisticated. So a white space device can sense the spectrum around it and understand where there are adjacent transmitters. It can also adapt and use different frequencies depending on where the capacity is available. There are two main mechanisms that are being proposed now in the US for protecting against interference with existing broadcasters. One is a geolocation system, which means that the white space device has a database of what broadcast transmitters are available in its local area. Using GPS or some other mechanism, the device can know physically where it's located. The second mechanism is to require the broadcasters or other users of the spectrum to put up beacons, essentially a kind of signal that will tell these white space devices not to transmit because there's something already operating in that frequency in that area. The FCC has launched a proceeding to explore opening up this white space capacity. As you might imagine, the broadcasters are opposed to this development. However, the computer industry, especially companies like Google and Microsoft, have gotten involved very aggressively to promote it. These companies understand, even though they don't provide communications or broadcast services, that this is a tremendous opportunity. The FCC is now testing a series of prototype white space devices to demonstrate that some of these techniques work to avoid interference. And even if the prototypes that are available today have problems, this is fundamentally a technical problem which is not going to be that hard to solve. The FCC understands that its goal is to make available as much capacity as possible. So I think it's very likely this white space proposal will move forward. The only question is whether it happens before or after the presidential election. But it's not a political issue that will depend on the outcome. Both parties understand the importance of opening up more capacity. So that's basically where we are in the United States. What's different between the process in Japan and the process in the United States? There are some specific differences in the two markets, as I've described, but the same opportunity exists everywhere. I think, again, the main thing that we've done right in the U.S. is to have this reform of spectrum policy go on at the same time as the digital television transition. Again, the U.S. spectrum policy reform is not just about auctions. As long as the approach is to make capacity available to the ones who can use it best, there are a number of mechanisms that can be used once that capacity is identified and made available. So I would conclude by encouraging policymakers here and elsewhere in the world to see the digital TV transition as being more than just a transition for television. When we look back 10 or 20 or 30 years from now, I'm confident that we will see the new spectrum capacity made available as more important than the transition of television service from analog to digital. There are many complicated issues to be dealt with, and it's important to realize that there are different industries here coming together, and they need to have incentives to work together and to reform. And it's a process, especially with regard to the television sets, that takes time. But we should not let the fact that not every single person has bought a new television set destroy the potential of this transition. We should not let the transition of the television sets destroy the potential of the overall transition. Completing this digital transition will create a tremendous amount of new innovation and new services. The real next generation network is a ubiquitous broadband wireless network. Anything that can be done to make available new wireless capacity for new services will promote new investment and new economic activity and new innovation. In this environment of so much globalization, I think it's essential that we all learn from each other and the experiences in different countries to get to this shared goal. Thank you again for having me here today.